Hello everyone, my name is Ajiman Esasafoa and this is my presentation on the hand gesture based command control for STELLA N2 Robot. My content includes project background, project description, project methodology, which includes data collection, model training and testing, and then my project results include high-level command and robot motion. So with the rise of autonomous vehicles, there arises the need to enable them to interpret human hand signals in real time for safe on-road human-robot interaction, in that when an autonomous vehicle is moving on the road, there's a need that in case of emergency, it should be able to respond in real time. And based on this challenge, I decided to control the STELLA N2 robot using hand gestures, and in the future, this idea may be adapted for use by real-world autonomous vehicles. So for this project, initially I was to use the RGBD camera, specifically Obec femtobolt, to collect the data, but because of situational challenges and the condition and current state, I decided to use the webcam instead. But then the webcam was still successful. And so what this project entails is that the camera is used to collect the data, and then the data is now fed into 3 different models for training, and then after that they are tested in real time. So the project methodology entails data collection, training, and then testing. So for the data collection, the data was in the form of visual frames captured with the help of the webcam sensor, and the data included 5 gestures, which was open palm, closed fist, left flip, right flip, and backhand, and they correspond to forward motion, stop, left motion, right motion, backward motion, respectively. And these 5 motions correspond to the W, S, A, D, and X letters of the teleoperation section of the STELLA N2 robot. So this is the forward motion capturing. And so for this one, if you look here, you can see that the label is none because at that time it had not been selected, and it's idle at this point. But then at this point, the label becomes forward and it starts capturing. So this is for when it was capturing forward motion. And then this is when it was capturing stop motion. So this is the closed fist, and this section is when it's saved. The label is going to save it to a stop, and then it's capturing in this section. And it's the same for left motion, right motion, and backward motion. So this is when the code is running and it is collecting the data. So it selects the label as, for example, backward, and then it captures it, and then it selects, for example, stop, and then it captures it. So it captured 40 frames per record. So for this data, each gesture was recorded 4 times, and each recording had 40 frames, which means it had a total of 160 frames. And each frame had 21 media pipe landmarks, which is the joints in the finger of the hand. And then each landmark had XYZ components. So in summary, each frame had a 63 value feature vector, which is what was fed into the training module. And this 63 feature vector is present in each of the frames. And as mentioned earlier, the frames were 160. So to know how many feature vectors there were, it will be 63 times the 160 frames. So training. The 3 modules were trained, KNN, SVM, and random forest, and they each had an accuracy of 1. But the first module, KNN, was selected. And that's a good selection because it's simpler and great for real time. It handles different lighting and distance well, and prediction latency is small. So in summary, KNN is a fine practical mode. The testing was in 2 phases. We tested via high-level command output, and we tested via robot motion. So the final project results were that, as mentioned earlier, we tested it via high-level commands, and we tested it via robot motion. So In the testing via high-level commands, we tested to see whether the gestures that were made towards the robot will produce the right high-level commands. For example, this is when I did a closed fist. So this closed fist produced the prediction stop. And so that meant that it had worked, the module had learned based on the data accurately, and so it produced stop when in real time I gave it a closed fist. The same thing happened for the left flip. The left flip resulted in left. Then the right flip resulted in right. And the backhand gesture resulted in backward. And then the open palm resulted in forward. So that meant that the testing via high-level commands was successful. These are recorded videos showing the results for the robot's motion. And I couldn't record these side by side. I couldn't record these simultaneously, but if you look at the pattern of my hand motion and the pattern of the robot motion, you can tell that it's responding to my hand gestures. This concludes my presentation on hand gesture-based command control for STELLA N2 robots. Thank you. Thank you for watching.